Hello, I am Abdulatiph Asher, and I will solve one problem from each of these topics. Before I begin, please hit the like button. Make it blue. Okay, so using molarity to express concentration. 2.56 gram of sodium chloride or salt is present in 100 ml of an aqueous solution. What is its molarity? So the formularity is moles of sodium chloride over liter of solution. So we do not have moles of the sodium chloride in this problem. So we will first find the mole. To find the moles of sodium chloride, the formula is mass over molar mass. The mass of sodium chloride is 2.56 gram, and the molar mass of sodium chloride is 58.44 grams per mole. Cancel the grams and we will solve for this. 2.56 over 58.44. So we get the answer, which is 0.044. Let's round off. So this is the moles of sodium chloride. Now that we have the moles of sodium chloride, we can now get the molarity. But notice that it is liter of the solution, but in the problem it is the milliliter. So we have to convert it to liter. So which will become like this. So we will put that into our scientific calculator. 0.044 mole over 100 parentheses open parenthesis 1 over 1000 milliliter close parentheses. We now have 0.44 mole per liter. So the molarity of sodium chloride present in 100 ml of an aqueous solution is 0.44 mole per liter. Next is the freezing point depression. Calculate the freezing point of a 1.6 meter of 1.6 mole of lithium fluoride water solution. Assume you are at sea level. So the formula for this is this. This is change in freezing temperature. Freezing point constant of water this is the freezing point constant of water, which is 1.86 degrees Celsius. This is the molarity of the solution in mole per kilogram, which is this. And this is used only for ionic compounds. It is the Van 't Hoff factor, which is the number of particles the substance will dissociate into. Now we'll put in the values, which is 1.86 degree Celsius per mole times 1.6 molarity times 2, which is the lithium fluoride will dissociate into 2 particles. Now we will cancel the molarity, the mole, and we will put the value inside the scientific calculator. 1.86 times 1.6 times 2. Now we have 5.952. or 995, which is the same. But this is not the final answer. We will get the temperature of the H2O, water, and the freezing point of water is 0 degrees Celsius. Minus that to the freezing temperature, freezing change, the change in the freezing temperature, which is negative 5.95 degrees Celsius. So this is now the freezing point of this solution. Next is constant volume calorimetry. A sample of methane weighing 0.5 gram was ignited in a bomb calorimeter. The water rises from 25 degrees Celsius to 27.91 degrees Celsius. The heat capacity of the bomb plus water is 9.16 AJ kilojoules per over degree Celsius. Determine the molar heat of combustion. First, we have to get the given values, which is this. The change in temperature is equals to the final temperature is 27.91 degrees Celsius minus the initial temperature. And so the change in temperature is 2.91 degrees Celsius. The specific heat capacity of the bomb plus water is 9.16 kilojoules per over degrees Celsius. So this is the formula. Heat system is equals to heat combustion plus heat cal, which is just the same with heat combustion is equals to negative heat cal and this. So we will use either one of this equation, and I will use this one. Okay. So negative heat cal is equals to heat capacity multiplied to the change in temperature. We will put in the values and cancel the degrees Celsius. Put the value, calculate it in the scientific calculator. And now we have the negative negative heat cal multiplied to -1 so that the negative in heat cal will be gone, and so we have this answer. This means that this is experience exothermal reaction, and heat cal is equals to heat combustion. It is just the same. Now we will get the molar heat of the combustion, this. So molar heat is equals to this over mass of the sample multiplied to the molar mass. Cancel grams to solve it in the scientific calculator. We have negative 643.528. There. Now we have the molar heat of the sample. This is now the molar heat of combustion in of this sample. Thank you, and that's all. And once again, press the like button.